more specifically a Cavendish banana. Now, you may have realized that unlike apples and pears, all bananas taste the same. And that's because 99% of all bananas sold internationally are Cavendish bananas. It's also without a doubt that this is the one fruit that humans consume the most of worldwide, with 80 million tons consumed per year. That's like 80 football stadiums filled with bananas. However, due to the recent arrival of a banana hater, this may all soon be history. Introducing the fearsome wilt tropical race, or TR4 for short. Sorry. A fungus that lives in the soil. Once the banana plant comes in contact with TR4, it begins to spread like wildfire. It starts with a few wilted leaves on one tree to eventually killing out the entire plantation within a year. It's gotten to a point where the farmer's only option after discovering TR4 is to pack up, depart, and start over on a fresh plot of land. We also can't just crossbreed the Cavendish because it's sterile and doesn't produce big seeds. We're going to have to reinvent the banana. Luckily, there are already laboratories tackling this and producing results. There are two ways to modify the genes of the banana, according to Hervé van der Stroom, a professor at the KU Leuven in Belgium. Finding a wild banana with a gene resistant to TR4 and introducing it into Cavendish is the first method. The second approach is to say, I see the genes in the Cavendish, but it doesn't have the right mutations. Can we somehow modify it so it can be resistant to TR4? A utility called CRISPR-Cas9 will be used to accomplish all of this. Lena Tripathi from the Nairobi branch of International Institute of Tropical Agriculture has a fresh viewpoint. What if we subtract from the genes and modifications instead of adding to them? She found specific genes in the Cavendish that makes it more prone to the disease, and she's knocking them out, or more simply eliminating them. Now let's first talk about why this is so important. This is more than just saving the Cavendish. The banana is a staple food in many diets all across the world and also comes with plenty of health benefits. And the banana farmers' jobs are also on the line. In collaboration with the Bill and Melinda Gates Foundation, James Dale from the Queensland University of Technology is developing a new kind of banana that's particularly rich in vitamin A and iron. There are many children in the still developing countries that lose their eyesight due to nutritional deficiencies, so they're hoping that this new type of banana will help save them. Now, remember the wild banana we discussed earlier with the gene resistant to TR4? Yep, we found it. The Musa acuminata is a wild diploid banana that inhabits great resistance to TR4. Its RGA2 gene is the fundamental resistance mechanism. Additionally, nematodes, also known as roundworms, have a mutation called CEG9 that also makes them resistant to TR4. Now, you might be wondering, if this type of banana is resistant to TR4, why don't we just breed and import it instead? The thing is, this type is a diploid, meaning it inherits one chromosome from each parent, resulting in seeds. And do you want to know what a banana with seeds look like? It looks like that. Not even a starving monkey would want to eat that. James Dale and his colleagues performed a 3-year field trial testing the integration of these genes into bananas. And as you can see, 2 lines of transgenic Cavendish, one transformed with the RGA2 gene and the other with the nematode-derived gene CEG9, both remained disease-free. Now, since they're both bananas, the RGA2 genes are still present, the RGA2 homologs are still present in the Cavendish. However, it's expressed 10-fold lower. However, this expression can be potentially elevated through gene editing, meaning we won't have to transfer any genes, we just need to edit the original ones. There are still many technical obstacles we must conquer before we can sell these bananas in stores, like scalability and dependability, and also the acceptance of genetically modified bananas. But ultimately, if you had to choose between genetically altered bananas or no bananas at all, what would you choose? Thank you.